Hello guys, welcome back to Jyoti classes, and today we will be taking few more questions. So let us start with today's first question. And the first question states that in the presence of weak magnetic field, the following transition is observed. 2D 3 by 2 to 2S 1 by 2. The type of Zeeman is observed. Options are given as normal, anomalous, both and none. Here we are aware that there are two types of Zeeman effects. One is normal Zeeman effect and the another one is anomalous Zeeman effect. So I hope you all are aware of those things. And from the given question, just you have to take the transitions from D state to S state. Take the first transition that it is taking place from 2D 3 by 2. Find the Landy G factor for the given question. For the given transition 2D 3 by 2, here we get the respective values of S, L and J. For 2D 3 by 2, S is half, L is 2 and J is 3 by 2. Just substitute in the formula and you will get the answer for Landy G factor. G is equal to 4 by 5 for transition in 2D 3 by 2, which is taking place to S 1 by 2. Similarly, find the Landy G factor for 2S half. Respectively, the values of S, L and zeros are taken from there. Do the simple calculation, you will get the value as 1. From this, it is clearly shows that the Landy G factor for 2D 3 by 2 and 2S 1 by 2 are different. Hence, it is an anomalous Zeeman effect. That is option B is the correct one. Okay. So, let's move on to the next question. That is, the question states that the time period of oscillation for the pendulum with an extended mass that is free to oscillate horizontally is given by. Here from the question it is clear that by the help of using the standard time period formula for the compound pendulum, we have to find for the if the extended mass which is free to oscillate in horizontally. Just first step for this to solve this question is take the time period formula, that is T is equal to 2 pi root of I by mgl, where I is the moment of inertia. Next, now the total moment of inertia is given as I m k square plus L square into like just substitute the value of moment of inertia in the given time period and just take m as a common, and both the m from the denominator as well as in the numerator cancel it out. So the remaining value will be T is equal to 2 pi root of k square plus L square by gl. It is as simple as it is. Once if you know the value of moment of inertia, substitute in the standard time period formula for the compound pendulum, and hence the answer C is the correct option for the given question. Okay. Now moving on to the next question. This question states that consider two objects having the rest mass m1 and m2 respectively, moving with an relativistic speed, and kinetic energy of the objects are k1 and k2 respectively. If 2m2 E1 is equal to 5m1 E2, where E1 and E2 are the total energy of the object, where K1 is only 5% less than E1, then we have to find the kinetic energy of the sound object in terms of E2. Okay. Seeing the question, you may think that it is so complicated, so many data is given. In that you have to select the data, use that data to solve your answer. Okay, let us solve this question in a very simple way by step. First one, we know that the total energy for the first object. Here it's clear that there are two objects with their rest mass m1 and m2. So now the total energy for the first mass is E1 is equal to m1 c square plus k1. Here c is the speed of the light. Next, similarly for the second object, the total energy is E2 is equal to m2 c square plus k2. Here K1 value is mentioned in the question, where K1 is 5% less than the E1. So the value of 5% is 0.951. Just substitute that value in the above equation 1 of the total energy of the first object. Okay. Now then simplify that, you will get the answer for E1, that is 20 m1 c square. After getting that answer, find the value of K1. When you substitute the value of E1 in the given K1 value, the value will be 19 m1 c square. For that given question, for the given K1 value from the question, you can see here that in the question it's already mentioned that 2m2 E1 is equal to 5m1 E2. We got the value of E1, substitute that value and you will get, your answer will be reduced to, see, 2m2 E1 is equal to 5 times m1 E2. E1 value is substituted in the given question and you will get the value of E2. Substitute the value of E2 in the equation number 2 and the value of K is 7 by 8 E2. Okay, for these type of questions you normally need the practice of solving any questions with patience in step by step. So it was not difficult to find the value of K2 if you were aware of this concept, how to proceed it. Okay. Okay, next let's move on to the next question. Okay, this question says that positronium is an atom made up of electron and an positron. Given the Bohr radius for the ground state of the hydrogen atom to be 0.53 angstrom. The Bohr radius for the ground state of the positron is, just they are asking us to find the ground state of the positron. We know that what is the radius for the nth orbit. Radius for the nth orbit is Rn is equal to A naught me by mu. Mu is the reduced mass, that is mu is equal to me by me plus me, that is mu is equal to me by 2. Okay, here positron mass is mu. Okay, that is me by 2. Just simplify this, 2 will go on the upper side, me by me will get cancelled, so the remaining will be the radius of Rn is equal to 2 times A naught. Here given A naught value is already given, that for the hydrogen atom the ground state Bohr's radius is 0.53 angstrom. Substitute the A value and the radius of positron in the ground state will get as 1.06 angstrom.